After this lesson, students will be able to solve equations using distributive property, combining like terms, and equations with variables on both sides of the equal sign. Students will also be able to state any restrictions. Try these 3 questions, so pause the screen and resume when you're ready. For number 1, we have to start with the distributive property. We're distributing positive 3 to 2x and to negative 5, which gives us 6x minus 15. And then we recopy the rest of the problem. Now, we combine like terms to get 2x minus 15 equals 31. Using inverse operations, I add 15 to both sides of the equal sign. So I'm left with 2x equals 46. By dividing both sides by 2, I'm able to isolate x, so x equals 23. We're just negative 3, not just the 3. So I like to put a circle around it so I don't forget about the negative sign. Negative 3 is distributed to 2k and to 4, which gives us negative 6k minus 12, and then we recopy the rest of the question. Combining like terms, negative 6 and negative 12, we get negative 6k minus 18 equals 18. We now use inverse operations to isolate k. So add 18 to both sides of the equal sign. Negative 6k equals 36. Divide by negative 6. And we get our final answer, k equals negative 6. Number 3, 1/3 x equals 1/2. Well, 1/3 is being multiplied by x in this question. So the inverse operation would be to divide both sides by 1/3. When we divide by a fraction, we can multiply by the reciprocal. So I'm going to multiply both sides of the equal sign by the reciprocal of 1/3, or 3 over 1. Since 3 over 1 times 1/3 is just 1, I'm left with 1x, or x, on the left side of the equal sign. On the right, I can multiply across to get 3/2. My final answer, x equals 1.5. Solve equations with variables on both sides. Collect the variable terms on the side with the greater variable coefficient. 7x plus 19 equals negative 2x plus 55. Our goal is to get on one side. In order to get rid of the negatives, I can x to both sides of the equal sign. Negative 2x plus 2x cancels out. Now I'm left with 9x plus 19 equals 55. Using inverse operations, I subtract 19 from both sides. So 9x equals 36. Divide by 9, and we're left with x equals 4. In our second example, we have t's on both sides of the equal sign. We also have to use distributive property in order to get rid of the parentheses. So I begin and to negative 2. 6t minus 12 equals, and on the right side I'm distributing 2 to 9 and to negative 2t. So 18 minus 4t. Now I need to get all my t's on one side of the equal sign. So I'm going to add 4t to both sides. It cancels on the right, so I'm left with 10t minus 12 equals 18. Add 12 to both sides. 10t equals 30. divide by 10, and we're left with t equals 3. Huge questions, so pause the movie, and when you're ready, you may resume. Number 1, by distributing y into negative 3. 2y minus 6 plus 6 equals 70. I can then combine like terms. Oop. That. Technical difficulties. Okay, so now this was a 70. Sorry about the technical difficulties. And now we can combine like terms. The negative 6 plus 6 equals 0. So I'm left with 2y equals 70. Divide both sides by 2, and we're left with y equals 35. Just m into 9, so 4m plus 36 equals, distribute the negative 3 to the m and to the negative 4. So we get negative 3m plus 12. Get all the m's on one side of the equal sign, so we add 3m to both sides. 7m plus 36 equals 12. Subtract 36 from both sides. So we get 7m equals negative 24. Divide by 7, and we get m equals negative 3 and 3/7 as our final answer. Find the value of x. You may remember from previous courses that these are called vertical angles and that vertical to one another. So 6x plus 3 would equal 8x minus 21. I gather all of my x's on one side. This time I'm going to move them all to the right side since 8x is greater than 6x. So I'm subtracting 6x from both sides, and I'm left with 3 equals 2x minus 21. Add 21 to both sides. 24 equals 2x. Divide by 2, so x equals 12. Since the question said to find the value of x, we found that it was 12. However, sometimes they may ask for the angle measure, in which case, plug in 12 for x. What is the angle measure? Six times 12 plus 3 gives us 72 plus 3, or 75 degrees. Solving a formula for one of its variables.
Here's a familiar formula, the formula for the area of a triangle. For the record, formula is defined as an equation containing two or more variables that is used to solve practical problems. This formula tells us how to find the value of A, the area of a triangle, when the values for the other variables, B and H, or base and height, are known. You've probably used this formula several times during your math career to find the area of a triangle. But have you ever used this formula to find the height of a triangle? Take a look at this triangle. Its area is 60 inches squared, and its base is 12 inches. But what's its height? We can use a little algebra to find out. To find the height of the triangle, we'll have to plug the given information into the formula and solve for h. So, I'll put the area, 60 inches squared, in for a, and the length of the base, 12 inches, in for b. Now, we can solve the equation for the height, h. Pay close attention to the following steps. You'll see them again later. To solve for the height, I have to get h alone on one side of the equation. To do this, I'll need to get rid of the other factors that appear with the h on the right side of the equation, the 1/2 and the 12. For the first step, I'll eliminate the 1/2 by multiplying both sides of the equation by the reciprocal of 1/2, or 2. Simplifying on the left, I have 2 times 60, or 120. And on the right, 1/2 times 2 is 1, leaving me with 12h. Now, to get h alone, for the second step, I'll divide both sides of the equation by the length of the base, 12. 120 divided by 12 is 10, and 12h divided by 12 is 1h. So the solution is 10 equals 1h, or 10 equals h.
Yeah!
The height of this triangle, then, is 10 inches. And you see how the formula for the area of a triangle can be used to find its height. But, from experience, you'll probably agree that this is not the best use of this formula. It's much easier to use this formula to find the area of a triangle than it is to find the height of a triangle. This is because of the way that the formula is written. The area, A, is written by itself on the left side of the equal sign and is called the subject of the formula. The base B and height h are written in an expression on the right side of the equal sign. Written this way, we call it a formula for A in terms of the variables B and h. We can find the height of a triangle much more easily if we change the subject of the formula to h by solving for h in terms of the other variables, A and B. In this way, we can solve the formula for all triangles. Again, we'll start with the formula A equals 1/2 B times h and solve for h. The key is to treat the variables A and B as if they were numbers, using the same rules of algebra that you already know. As we transform this equation, look closely, and you'll see the same two steps that we just used. Do you remember what they were? First, we multiplied both sides of the equation by 2. And second, we divided both sides by the base. Let's begin. To solve this formula for h, we'll have to get rid of the 1/2 and the b on the right side of the equation. To eliminate the 1/2, we can multiply both sides of the equation by the reciprocal of 1/2, or 2. There's that first step again. Simplifying on the left, 2 times a is 2a. And on the right side, 1/2 times 2 is 1, leaving us with bh. Then, to finish solving for h, we'll carry out the second step, dividing both sides by the base, b. On the left, 2a divided by b cannot be simplified any further. On the right side, with bh divided by b, the b's divide out, leaving us with h. So the formula reads 2a divided by b equals h. And we've changed the subject of the equation from a to h.
So let's do one together. For example, the formula for the area of a trapezoid is a equals 1/2 times the height times the quantity of b sub 1 plus b sub 2. Solve the formula for h. So first, we write the formula. Equals 1/2 h times b sub 1 plus b sub 2. Since I'm trying to isolate h, I need to get rid of the 1/2 and the quantity of b1 plus b2 using inverse operations. Currently, we're multiplying 1/2 in h, so the inverse would be to divide by 1/2 or multiply by its reciprocal, which is 2. So I'm going to multiply both. Now I'm left with 2a equals h times the quantity of b sub 1 plus b sub 2. Now, h is being multiplied by the quantity of b sub 1 plus b sub 2. So the inverse would be to divide both sides by b sub 1 plus. So our final answer, with h isolated, is 2a over b sub 1 plus b sub 2. Now you try. Pause the screen as you work out the question and resume when you're ready. In order to solve the formula for b1, I'll have to use inverse operations. To get rid of 1/2, which is being multiplied, I use the inverse, which is dividing by 1/2, or reciprocal. Multiply both sides by 2. Now I have 2a equals h times b sub 1 plus b sub 2. To get rid of the h, I divide both sides by h. 2a over h equals b sub 1 plus b sub 2. I can take those out of parentheses since now it's not being multiplied by anything. Finally, to isolate b sub 1, I can subtract b sub 2 from both sides. So our final answer is 2a over h minus b sub 2, which equals b sub 1. When you're ready, you can resume. The formula for the surface area of a rectangular prism 2 times the quantity of length width plus length height plus width height. Solve the formula for W. First, I'm going to get rid of the 2. So I divide both sides by 2. Next, I'm going to subtract LH, since there is no W in that term. So now I have A over 2 minus L times H equals LW plus WH. Since two separate terms have a W in them, I'm going to use the reverse of the distributive property so that I can just write my W once. So on the right side, when I pull out W from each of my terms, I'm left with L plus H. Notice how if I were to redistribute the W, I would end up with what I began with. Finally, since W is being multiplied by the quantity of L plus H, I can divide both sides by the quantity of L plus H. I do have to put it on both terms on the left side. Now our W is isolated. Solve each indicated variable. Try this on your own, and when you're ready, you may resume. I'll begin by multiplying both. 2s equals gt squared. Since I'm isolating g, and g is being multiplied by t squared, I do the inverse, which is dividing both sides by t squared. So g equals 2s over t squared. Solving an equation for one of its variables. This time, we're going to practice finding. So, we've got x over a plus 1 equals x over b. To get rid of the denominators, I can multiply every single term by the least common multiple of the denominators, or the least common denominator. The least common denominator would be AB. So I multiply each term by AB. Since here the A's cancel out, I'm left with BX. 1 times AB is AB. And here the b's cancel out, so I'm left with ax. Now I need to get all the x's on one side, since that's what I'm trying to isolate. So I subtract bx from both sides. ab equals ax minus bx. Since I'm trying to isolate x, I need only one of them. So I'm going to use the reverse distributive property to separate the x out from these terms. So now I'm left with a minus b. Finally, I can divide both sides by the quantity of a minus b. X equals ab over a minus b. Now, when talking about restrictions, we need to think denominators cannot equal 0, or it would be undefined. Therefore, we look through our question, both the work and our answers, to determine what A and B cannot equal. So from the beginning of the question, when A, this tells us that A cannot equal 0. B was also in the denominator, so B cannot equal 0. We also have a minus b in the denominator. So that means that a minus b cannot equal 0, or in other words, a cannot equal b. So answer, x equals over a minus b, where a cannot equal 0, b cannot equal 0, and a cannot equal b. For part 2, What do you know about x in the equation y equals the square root of x if y is to be a real number? Well, x could not be a negative number, so x would have to be greater than or equal to 0. Now you try these two questions, so pause your screen and resume when you're ready. Number 1. Solve each equation for x and find any restrictions. So I try to get x by itself. I begin by adding 15 to both sides. ax plus bx equals 15. Using reverse distributive property, I can factor out an x to get x times a plus b, which equals 15. Finally, I divide by the quantity of a plus b, so x equals 15 over a plus b. Now for restrictions, I look through the entire problem. The only thing in the denominator at any point is the a plus b, which tells us that a plus b cannot equal 0, or a cannot equal negative b. For part 2, we begin by subtracting 8. X over a equals b minus 8. Multiply both sides by a. Keep in mind we're multiplying the quantity of b minus 8 times a. So x equals a times b minus 8, which could also be written as x equals ab minus 8a. The only time we had anything in the denominator was when a was in the denominator. So a cannot equal 0. Solve and state any restrictions on the variables. Pause the screen to try this on your own, and resume when you're ready. So I'll begin by distributing, and I have ax plus ac equals bx minus bc. Get all the x's on the same side. So I subtract bx. ax minus bx plus ac equals negative bc. To isolate the x, I'm going to subtract ac from both sides. Use the reverse distributive property, or factoring, to factor out an x. And divide both sides by the quantity of a minus b. So x equals negative bc minus ac over a minus b. Going through the problem, the only time we had a denominator was a minus b, which means that a minus b cannot equal 0, or that a cannot equal b. Solve each equation. Pause the screen to try the problem on your own, and resume. For this problem, I need to get rid of the denominators. So I have to search for the least common denominator. I can use 30. If I multiply each term by 30, my denominators will cancel out. 15x plus 6x plus 10x equals 930. Combine like terms. 31x equals 930. Divide by 31, and x equals 30. Real-world connection. A rectangle is twice as long as it is wide. Its perimeter is 48 centimeters. Dimensions. Hint: draw a picture and define your variables. So I draw my rectangle, and I let let W equal the width. It's twice as long as it is wide, so that means that 2W would equal my length. W and 2W. The perimeter is 48 centimeters. So adding up all the sides, 2W plus 2W plus W plus W, I get 6W equals 48. Divide by 6, W equals 8. So the dimensions would be that the width is 8 centimeters, and since the length is twice as long, the length is 16 centimeters. Find 3 consecutive even integers whose sum is 168. Equal the smallest integer. Since they're consecutive, x plus 1 equals the second integer. Oh, but I'm sorry, they are consecutive even integers, which means I have to skip one number. So x plus 2 would be the second integer. And since we're skipping a number again, since we're only doing even integers, x plus 4 would be the largest integer. The sum is 168. So x plus 2 plus x plus 4 equals 168. Combining like terms, we get 3x plus 6 equals 168. Subtract 6, we get 3x equals 162. And when I divide both sides by 3, I get x equals 54. So the 3 consecutive integers would be 54, which is the smallest one, or x. The second would be x plus 2, so 56. And the third is x plus 4, 58. Those are 3 consecutive even integers whose sum is 168. Rachel and Michelle were on trains traveling in opposite directions. Rachel's train was traveling 15 miles per hour faster than Michelle's train. After 5 hours, their trains were 575 miles apart. How fast was each of their trains going? Well, if you're and Rachel's train is traveling in this direction, and Michelle's train is traveling in this direction, and they end up 575 miles apart. Suppose Michelle's train is traveling at a rate of r. Then Rachel's train would be traveling at r plus 15, 15 miles per hour faster. Distance equals rate times time. So Michelle's train travels 5 hours times her rate, or a distance of 5r. Rachel's train travels r plus 15 times the time, 5r. Rachel's distance plus Michelle's distance equals 575 miles. So 5 times the quantity of r plus 15 plus 5r equals 575. Distribute 5r plus 75 plus 5r equals 575. Combine like terms and isolate the variable. So 10r equals 500. Divide both sides by 10, r equals 50. We defined r as the rate of Michelle's train. So Michelle, her train traveled 50 miles per hour. Rachel's train traveled 15 miles per hour faster than Michelle's, or 65 miles per hour.